Lesson 1-4, like terms and the distributive property. Our essential question is, how do you determine if terms are like terms? Well, our first vocab word is like terms. The definition of like terms kind of makes sense because they're terms that are alike. But more specifically, the part of the terms that are alike is the variable part. And that variable part has to be exactly the same. Remember that the variable part is the part with the letters. So they have to have the exact same variable part. The coefficients, or the numbers that are in front of the variables, those don't have to be the same. So a coefficient is a number in front of a variable. Co as a prefix, co means like goes together. So if we had a term like 5x, the 5 is called the coefficient. It goes with the variable. And the x is your variable. We're now going to work with the distributive property that we talked about in the last section, and we're going to use that distributive property to simplify. So our first example says 7 times 3w minus 5. When the 7 is written outside of the parentheses, whether it's written in front of the parentheses or after the parentheses, doesn't matter, but if it's written right next to the parentheses, it means that it's being multiplied. We used that idea with PEMDAS in the very first section of this chapter. So if I distribute and multiply my 7 times everything in the parentheses, it means 7 times 3w minus 7 times 5. 7 times 3w is 21w, and 7 times 5 is 35. So 7 times 3w minus 5 is 21w minus 35. Our next example is 12 times y plus 3. If I distribute 12 times y plus 3, it means 12 times y plus 12 times 3. 12 times y is 12y, and 12 times 3 is 36. So 12 times y plus 3 is simplified to 12y plus 36. Our next example is 8 plus 4n. And notice on this one, the 2 is written after the parentheses. That does not matter. It still means it's being multiplied. So if I multiply 8 times 2 plus 4n times 2, I will get 16 plus 8n. Now these answers are simplified because the terms that are left are not like terms. They do not have the same variable part. So my 16 plus 8n down on the bottom does not mean 16 plus 8, which is 24. It doesn't mean 24 or 24n. Those are not like terms. They do not have the same variable part, so they cannot be combined. We have a couple more examples for distributing, and on these I'm going to distribute without writing out that multiplication step. So 4 times 7x, 4 times 7 is 28, so 28x plus 4 times 2 is 8. So I'm skipping that step where I'm showing you 4 times each of those things. because I think that you probably got the hang of it. Next one, x plus 5 times negative 2. Again, I'm going to skip that step, so I'm going to distribute. X, negative 2 times x is negative 2x, and negative 2 times positive 5 is negative 10. Be really careful with the signs when you're distributing with negative numbers. And my last one, 3x plus 1 multiplied by 8, so distribute. 3x times 8 is 24x plus 1 times 8 is 8. This one actually should be like that. Okay. Now, we're going to talk a little bit more about those like terms. This is a click and drag activity. Now, the first person that comes up to click and drag a term can pick any term and can put it in any circle. Now, after that 5x has been placed, in the same circle with the 5x, you can put only terms that are like terms with it. So, for example, 4y has a different variable part. That means that they can't be in the same circle. You've got to start your own circle for 4y. Now, let's say that I go to my 6y. I can put that one with the 4y because they've got the same variable part. The plain number 22 is a constant. It doesn't even have a variable, so that would get its own circle again. X squared, you might think goes with the 5x. It does not, because x is not the same as x squared. X squared. When the exponent changes on the variable, it's not a like term anymore. I've got a 13x that can go with my 5x. I've got a 7x squared that can go with that plain 1x squared. My 9y can go with 4y and 6y. 4 can go with the 22, and 7y to the third is all by itself. So this is just to get you to be able to sort terms and determine whether or not they're like terms. So remember, like, the part that has to be alike is the variable part. That means the letters, including the exponents on them. If there are exponents on them, those also have to match. Okay, now we are going to combine some like terms here. If terms are like terms, you can combine them by adding or subtracting them depending on the sign in front of the term. So I've got this term 3x over here. It's a positive 3x. And then I see a like term to go with it, the 2x, and I'm keeping the plus in front of it so that I recognize those are both positives. If I combine them, 3 plus 2 is 5, I get 5x. Now I've got another set of like terms, this positive 5 and positive 6. If I combine those, I get positive 11. So my simplified answer is 5x plus 11. Okay, the next one. I have a 10x and I have a minus 8x. If I combine those, 10x combined with the negative 8x or 10x minus 8x, 10 minus 8 is 2, so I would have 2x. Then I've got this 2y that's kind of hanging out by itself. It doesn't have any like terms. And I've also got this negative 4 without any like terms. If they don't have like terms, they don't go away. You still need them in your simplified answer. So I could only combine one pair of like terms here. My final answer is 2x plus 2y minus 4. All right, next up. I am going to start with the highest exponent I see. 4y to the third does not have any like terms, stays by itself. Then I'm going to move over to this y to the second power, and it's a minus 8y to the second power. Again, no like terms for that one. Then, my last ones, I've got a positive 2y and a positive 5y. Those two can be combined to give me plus 7y. So 4y to the third minus 8y squared plus 7y is my final answer. Okay, the last one of these, I'll start with x, alphabetical order. So negative 7x is my first term. It doesn't have any like terms. positive 15y combined with negative 2y. So that would be positive 13y, 15 minus 2. And I've got two plain numbers, positive 3 and negative 9. If I combine those, I get negative 6. So negative 7x plus 13y minus 6. There isn't a specific order that you have to write these terms in. So if you have them written in a different order, it's fine, as long as the signs in front of them match the ones that I've got up here. So on that last one in particular, the 7x has to have the minus in front of it, so does the 6. And then the 13y is the only part that's a positive in that term. Okay, now we're going to combine the ideas here. So first we're going to use the distributive property, and then we're going to combine like terms if we can combine like terms. So distribute first. So kind of like with PEMDAS, when you see parentheses in your problem, you need to take care of those first. So I need to distribute here. So 7 times 3x is 21x, plus 7 times 4 is 28. Now I can add together my like terms. So 3x plus 21x would be 24x. So my final answer is 24x plus 28. Another one like that. Distribute first again. So distribute 4 times 2x is 8x, plus 4 times 3y is 12y. And then I can put together my like terms. My like terms are the 8x and the 5x. They're both positive. So 13x plus 12y is my final answer. And the last one of those, a little bit more complicated. Be careful with your signs. Okay, so I need to distribute first. Negative 3 times x is negative 3x. Negative 3 times negative 4 is positive 12. And then distribute over here on the 2. 2 times 5 is 10, so plus 10. 2 times 3x is 6x, plus 6x. Now, put together your like terms, starting with my variables. Negative 3x plus 6x would be positive 3x. And positive 12 combined with positive 10 is positive 22. You should be able to write a summary now that answers your essential question. Please make sure that you restate the essential question when you're answering it, and make sure that your answer is in complete sentences.